So in this case, we are going to consider our typical exam question as we are preparing ourselves for the exams, which are ahead of time. We need to work out as much questions as we can. It is very, very important as you are preparing for your exams. So in this case, we are given that is a term one controlled test, which we are going to consider for our mathematics, and it was 50 marks that we are given, which is a duration of 1 hour. So we're just gonna see with our questions and how it is possible to cover up all these questions that we are given. So the first part, remember that you are supposed to go through your instructions, information that you're given, especially on the rounding off of your answers if necessary. Answers should be rounded off to 2 decimal places unless stated otherwise. So make sure you read everything, guys. You present your work properly, neatly in your writing. Make sure that everything is properly presented. So I'm not going to waste time. Let us quickly rush through our questions and see how we're supposed to attempt these questions. On question number 1, you are given to solve for x. Moment you are solving for x, it is for any letter that you are given. Is it solved for M? Is it solved for N? Is it solved for Z? Whatever letter that you're given. So in this case, we are solving for the letter X. It is that we are dealing with equations or inequalities. So inequalities, remember, you solve for X. Equations, you solve for X. All right? Expressions, you expand the bracket. When you're dealing with expressions, be careful there, because expressions, we do not solve on expressions, we simplify. When it is a condition that you're asked to simplify or to evaluate whatever that you're given there, that is the part of your expressions. But equations and inequalities, so the part of solving, you're supposed to expect that under equations and inequalities. So this is where we are supposed to expect our solving for x. So like I said, guys, this is what we're given. 1.1 we're given, that's x into 5x plus 2. So that is equal to 0. That is what you're given on the first question. You're asked to solve for x. Remember your zero product, the zero product, zero concept. The product of a and b to be equal to 0, it means a must be equal to 0 or b must be equal to 0 as long as there's a product. So there we've got a product. That's x multiplied to 5x plus 2. So it is either one of these two must be equal to 0. So you're saying x is equal to the 0, or this other part is equal. It's a multiplication. It's a term and a bracket like that. You're supposed to use the same concept. So this bracket also must be equal to 0. So this is what you're going to have. 5x plus 2 is equal to 0. So already, as you can see here, we've got a solution. So we need to solve this part, obtain the value of x. So that was 5x is equal to 2. To the other side was going to be a negative 2. Simply divide by 5 by 5. So that is the value of x, minus 2 over 5. So as you can see, we've got this solution and these solutions. These are the two solutions that we are supposed to expect to have for the 2 marks that we are given there. All right, let's consider another question and see, which is 1.2. If you have to check, they were given it is to solve an equation, which is fine, just like a normal equation. But later on, they're writing a certain statement. They're correct to 2 decimal places. Correct to 2 decimal places. The moment that they specify that this is correct to 2 decimal places, guys, we cannot work out with the factorization method. We cannot work out that way. So it is either we are going to use completing of the square method, this one. You're going to have a quadratic equation there. So it's either to solve that, you're going to use completing of the square method, completing of the square. So it's either you're going to complete the square or you are going to use the quadratic formula. We are going to use the quadratic formula. Remember, these two are part of our syllabus. Using completing of the square, it's part of your syllabus. Using of the quadratic formula, it is also part of your syllabus. So you have to be careful there. All right, so let us see our equation. I'm going to start with the quadratic formula. Since most of us, that is what you use, then we're going to work out also with the completing of the square method. Remember, I talked about these methods. So that is x into 2x minus 3 is equal to 4. So make sure that you expand the bracket. As you can see there, we must distribute here by x, which is outside of the bracket, to multiply everything. So that's x times 2x, which is going to be 2x squared, x, and the minus 3 is going to give us minus 3x. That is equal to 4. So as we can see, we formed a quadratic equation. The highest exponent there is 2. So you're supposed to work out or to have the format of the equation. Remember your format, ax squared plus bx plus c is equal to 0. So meaning so you're going to take the constant to the other side of the equation so that we remain with one side being equal to 0. So that was going to give us 2x squared minus 3x. So 4 to the other side of the equation is going to give us a negative 4. That's equal to 0. We have formed an equation that now we are going to solve using our formula, which is our quadratic formula, which states that x is equal to what? Minus b. Remember, that is plus or minus the square root of b squared minus 4ac, like this. Everything is divided to 2a. So as you understand, a from the coefficient of x squared, b the coefficient of x, c being the constant. So in that manner, we can say that what is representing our a is 2, the coefficient of x squared. What is representing our b is the coefficient of x, which is a minus 3. What is representing c is minus 4, which is our constant. So in that case, we are going to solve for x. That is, x is equal to minus b, that is minus b. What is our b? Take note, our b there is a negative 3. The b that we are having is already carrying what? A negative. So take note there. So it's going to be negative, negative. So that is going to be a negative 3 like this, plus or minus the square root of b squared minus 4ac. So this is your b, remember? So you're going to have that minus 3 squared minus 4 times a. Remember, your a there is 2, and your c is minus 4. That's a negative. Remember, I said, guys, you can just open brackets when you are solving. So this is over 2 times a. 2 times a. Our a there is what? Is a 2. So that's 2 times 2. So that is what you're going to have. And I told you guys, whenever you are working out your quadratic equations using the formula, just try to simplify these numbers that are under the square root. Those numbers under the square root. So we know that a minus and a minus is going to give us what? A plus. So this is going to give us a positive 3. Then we're going to have plus or minus the square root of. So this is what I'm trying to say. Simplify these numbers that are under the square root. So that was going to give us a 41. The numbers, only these ones under the square root. Do not use the square root, just the numbers under the square root. That was going to give you a 41. Then 2 times 2, which is a 4. From there, we can obtain our exact solutions from what we are having there from our calculator. We start with a plus, then we're going to go to a minus. So a plus was going to give us 2,35, or x is equal to minus 0,85 if we work out with a negative. Make sure, if you do not know how to round off your answers, remember that's part of rounding off with your answers, is part of your simplification. Also, you must be able to round off your answers, but your calculators, they also can help you to do that. Okay, remember, this is what we want. So we need 3 plus, let us say 3 plus the square root of 41 like this, divided by 4. So that was going to give us 2,35, and so on and so on. So we can round off to 2 decimal places as we are given our instruction. So how can we round this? you press this shift. You must see the S there on your calculator. Then go to the setup. You're going to fix your calculator on number 6. Then you press 2. You want to round off to 2 decimal places. So the number that you press is the number representing the number of decimal places. If you want 1 decimal place, you press 1. If you want 2 decimal place, you press 2. 3 decimal place, 4 decimal place. So as we need 2 decimal place, so you press 2. All right. So if we go to that SD, this one, it will give our answer to 2 decimal places. So that is the same thing, guys. Even if we are to put a negative here, let us change and put a negative. You see that your answer will be already fixed to 2 decimal places, negative 0.85. So those are some of the things that, guys, that you need actually to know as you are working with your calculator. You need to understand that. So this is what we had. Using the quadratic formula, we managed to solve this quadratic equation. All right, so on the completing of the square method, this is what I want us to understand, because like I said, we could have used the completing of the square method. So definitely you're going to expand your brackets, you formulate your quadratic equation as usual. Let's say this is where we are, because what we need is to formulate the quadratic equation first. The format of your quadratic equation is this one. Yes, you could have left it at that stage where there is a 4 like that. It depends. You can take that 4 to the other side. I talked about, guys, these type of equations using our completing of the square method. So make sure that you do watch the videos on the introductions. So anyways, that is another way that we could have used to solve using completing of the square method. We have expanded. This is where we are. So I'm going to take that into continuation from this point. I'm going to take this into continuation from that point. Remember, this is what we have now. We have got 2x squared minus 3x minus 4 is equal to 0. This is the expansion part was going to be the same. You're working with the quadratic formula. You're working with the completing of the square method. You expand first. This is where you are. Remember, using the completing of the square method, the coefficient of x squared, I said it must be a 1. It must be a 1. So how can we make this to be a 1? We must divide by 2. So let's divide by 2. Each and every number or each and every term that you see there must be divided by 2. So that is it. So you're going to have x squared. This is 2, sorry, that's a 2 here, minus 3 over 2x minus 4 and 2, that's a minus 2, is equal to 0 like this. Remember, we are dividing each and every number that we see by 2. So using our completing of the square, I said if the coefficient of x squared is 1, like what we can see here, we are going to determine half the coefficient of x squared, half the coefficient of x, the coefficient of x, not the coefficient. Where did I get the squared, guys? All right, like everything squared. The way I referred it there, maybe someone got confused. I'm saying half the coefficient of x. This one is the coefficient of x. You determine half of it, then squared like this. Not to say this one, no. Half the coefficient of x, but you must square the whole bracket. So remember, this is the coefficient of what? The coefficient of x. This is the coefficient of x. This is a revision, guys. I talked about this on the introduction. Make sure you watch that. You can simplify this, like I said, this is half of minus 3 over 2. Use your calculator. Half of minus 3 over 2 is minus 3 over 4. Then you're going to have that as a squared. And if you square this, negative 3 squared, that's a 9. 4 squared, that's a 16. Or you can just use your calculator there. With this square, we are going to add, and suppose this is a normal equation that we have. So we're going to add this and also subtract that. Half the coefficient of x squared, everything that we are doing this rough working in, this is what we got. So we're going to add this and subtract it. But like I said on the explanation, For you to understand, yes, we're supposed to add this. You can just use this one instead. So you can use it as x squared minus 3 over 2x. Remember, we add our square. We also subtract it. You can use this 10 over 16. I'm not saying it's wrong. You can use that. Still one and the same thing. So we're going to add our square. That is minus 3 over 4 squared. Then we subtract the same square, meaning to say we are just using 9 over 16 minus 9 over 16. That is what we are simply having there. All right. The minus 2 remains as it is. So that's equal to 0 like this. So as you can see, adding and subtracting the square does not affect our question here. If you remove this, you are still having the original question. You are not supposed to change the question the way that it is presented there. But what is the advantage of adding and subtracting this perfect square that we just added now? It allows us to factorize. As you can see, we've formed a quadratic expression here. This quadratic part from x squared up to this part here. We are going to factorize. We factorize this. And I said on your factorization, because it's a perfect square, do not worry about much. Take the first term that is raised to the exponent of 2. What is it that is being raised to the exponent of to the power of 2? Because it's a perfect square expression. Whatever that we have completed here, we have completed a perfect square. We have completed a perfect square. So instead, we're just going to take the first and the last term that is being squared in a bracket. So that is what you're going to have. So you're going to take the x and the minus 3 over 4 in a bracket, you square it. So that is the importance here of knowing what is it that you are squaring here. Is it positive 3 over 4? Is it a minus? The number that you have here is the same number that you're going to put. If it was a positive, you're going to put a positive here. So be careful in your preparations, guys. So if you use the 9 over 16, no way it was taken from. It was taken from minus 3 over 4. So that when you write this bracket, you know where it was taken. Because most of you write this 9 over 16, but when you are to factorize here now, you write something else. So that's why I prefer that you write it as a squared like this, so that you know what you are dealing with. The first, this first one, and this last one. Those are the two that you combine. The rest, you can combine these. The rest, you can combine this. All right, that one is something that you can simplify. All right, so I want us to have our calculator. Remember, we fixed our calculator, so we must change back our calculator to the normal mode. So that's shift. We go to the setup, then we press 8 this time. Remember, you need to go back to the normal mode. So press 2. It is now back to the normal mode. It must not have the fix here. The only two things that you must have is this D and this mat. This D and this mat. That is what you're supposed to see on your calculator on a normal mode. So please make sure you check your calculator always. So let's simplify, guys. There's a minus there. So minus, open bracket, minus 3 over 4 squared. Or you can just write it as what? 9 over 16. It is up to you. It is one and the same thing. All right. That's minus 3 over 4 squared. This is same as minus 16. This one is same as 16. So we haven't changed anything. The minus 3 over 4 squared. We subtract the minus 2 that is also given. So you're going to obtain minus 41 over 16. All right. So that's a negative 41 over 16. This is where we are. We simplified what we can simplify on the calculator, factorization of the quadratic expression, then the remaining terms are simplified, combined together. That's equal to 0. All right, so let's move on. We're going to take the minus 16 to the other side. It gives us a positive, this minus 41 over 16. So x minus 3 over 4 squared is equal to 41 over 16. So introducing the square root, both sides, so that we remove this square. It was going to be the square root like this. Yes, you can simplify the square root of 16. Remember, I talked about this. You can simplify the denominator. You can leave it like that. It is up to you. But we can see that 41 is not a perfect square. So we cannot simplify that. So it is going to be x minus 3 over 4 is equal to what? Plus or minus the square root of 41. Everything over what? The square root of 16, we know that one, it's a 4. So that is what I'm trying to say there. So meaning to say, if you are given a condition like this, you can simplify the square root of, so you write it like that. The square root of 16 can be simplified. We know that one is a 4. So let us combine, guys. Take the minus 3. It crosses the equal sign so that it will be a positive. So it was supposed to be like this. 3 over 4 plus or minus the square root of 41 over 4. But what are we seeing, guys? The denominators are the same. So it means we are simply going to combine the numerators together because we've got what? Same denominators. So that's 3 plus or minus the square root of 41 like this. Everything over a 4. You can combine this. So if you do not want to simplify these guys to say the square root of 41, I do not know this one. You could have left it at that stage like this. X minus 3 over 4 is equal to the square root. So you just write plus or minus the square root of 41 over everything under the square root. Okay? Because you don't understand that this can be simplified on its own. This can be simplified on its own. Just leave it like that. Then you take the minus 3 to the other side, it gives you a positive. So it is going to be 3 over 4 plus or minus the square root of 41 over 16. Still, you can have your answers. Now you can use your calculator. This whole part is covered by the square root. But if you understand your laws of surds here, you can separate the square root of 41 on its own, the square root of 16 on its own. All right. Then you combine it to be a single fraction like that. Guys, everything that you're going to obtain there is still fine. So let us have our x values. As we saw, guys, this stage, we saw it from our previous question. We're going to take a plus. So our x from the plus was going to give us 2,35. From a negative value, our x was going to give us minus 0,85 to 2 decimal places. So we saw these answers from our previous quadratic formula, using the quadratic formula. That is one and the same thing. So this is how questions can be given. You have to be careful. Using completing of the square method, know your stages. The normal quadratic equation is still the same. After obtaining your normal quadratic equation, you start now to apply your completing of the square method. What is important at this stage? Half the coefficient of x, but you must square everything. So it's half the coefficient of x, then square the bracket. That is supposed to be added and subtracted on our equation. On the one side, when you're dealing with one side of the equation, on the left side, you add, then you subtract it. Factorization done from the perfect square expression where you consider the first and the last term in a bracket squared. Then you combine what is remaining. Then this is normal solving of equation that we are used to work out as many questions as we can. So there, if the method is not given, you choose which one you want to work with. Sometimes they do specify. Sometimes they do specify using this method. If they specify, you do not have a way. But in this case, it was just solved. 1.3 solve again for x. X squared minus x minus 6 is greater than or equal to 6. That's an inequality that we are given there. So we're dealing with inequalities. But our inequality was x squared minus x minus 6 is greater than or equal to a 6. Remember, I said when dealing with the inequalities, quadratic inequalities, the highest exponent there is 2. So it's a quadratic. Anything that relates to a quadratic, one side must be related to 0. If it is an equation, ax squared plus bx plus c must be equal to 0. When dealing with inequalities, that is where we are comparing to 0. Is it greater than? Is it less than 0? Is it greater than or equal? It must be compared to a 0. So meaning to say, let's have that quadratic expression format before doing anything. So what are we going to do? The 6. We can see that one of these sides is not compared to 0. So you must take the 6 to the other side so that we remain with a 0 there. So that's x squared minus x minus 6 minus 6. It was a positive, so it'll be a negative there. So minus 6 minus 6, that's a minus 12, which is greater than or equal to 0. It is now compared to 0. Once you are at this point, find the critical values. So finding of the critical values, you can start by factorization. This is a quadratic expression. So let us factorize first so that we can obtain our critical values. Remember, the coefficient of x squared there is 1. So meaning to say we're going to have x and x. So that x times x gives us the 1x squared. Focusing on the constant, the factors of minus 12, which will add up to a negative. What's that negative representing? A negative 1. So we need the products, guys, of minus 12. Two numbers. You multiply two numbers, you get minus 12. You multiply two numbers, you get minus 12. But when you add, you must get a minus 1. Numbers that you multiply to get minus 12 are so many. Minus 12 and 1, 12 and minus 1, minus 6 and 2, 6 and minus 2, minus 4 and 3, 4 and minus 3. There are so many numbers. But of all these numbers, which pair, when you add, you must get a negative 1. You see it was happening between this minus 4 and 3. Truly, if we multiply this, we're going to get a minus 12. But if we add this minus 4 plus 3, it was going to give us a minus 1 if we add. So these are the numbers that we are going to need here. A minus 4 here and a plus 3 as we obtain. So we're going to have minus 4 and a plus 3. So we can now determine our critical values. So what are the critical values? Those are the numbers that you had before, okay? From these numbers that you obtained, put them in a bracket, then you now find what is x. X value is going to be what? So x is going to be what? From our equation, we now solve it as an minus 4 into x plus 3 is equal. You solve it as like that. So to the other side, x will be a positive 4, or x is going to be 3 to the other side, it will be a negative 3. So these are the solutions that we are obtaining as our critical values. These are the critical values. These are the critical values, not the solutions to the inequality. Determining the solutions to the inequality, that's where now you bring those methods that I explained. Is it going to be the table method? Is it going to be the graphical method? Is it going to be the number line method? It is now up to you. Which one do you understand? So I want you to use your method, guys. I explained all the methods. Make sure you go through. But I'm just going to explain with the graphical method. Remember, on the graphical method, I said we can sketch our function the way that it was supposed to be. We've got solutions at minus 3 and at 4. So that's a 0 there, minus 3, positive 4. Then is the function from here we can compare with a 0 there. See that our function, it has 1, this one, the coefficient of a, this one. A is 1, meaning to say a is greater than 0. That is going to be a smiley shape like this, all right? So remember your grade 10 mathematics, guys. So it's going to be a smiley shape, something like this. So where are we going to have this function greater than 0? Greater than or equal to, remember when we say it is equal to 0, we're talking about the x-axis. In this x-axis, we know that y is equal to 0. So that is where the function is equal to 0 in the x-axis. But they're saying it must be greater, meaning to say it must be above 0. Which numbers do we find in the y-axis above 0? These are numbers above the x-axis. When we are talking about the y-axis, with the y values as they go up 1, 2, 3, 4. So we're talking of above the x-axis, meaning to say that is this region. Remember, guys, I talked about how to determine the solutions on the introduction using the graphical method. I said you do not take solutions that are on an open space like this one, this of a curve when it is a gap like that. There are no solutions there. So you take these ones, these wings, these ones, these ones. What is in between this one are supposed to be when it was less than or equal to 0. We're going to take below the x-axis. So our solutions, we're going to be in between minus 3 and 4. But this one is greater than or equal to. So we take above the x-axis, but above our curve, this side and this side. So how do we relate to this side? These numbers, minus 3, minus 4, minus 5, compared to minus 3, they are less than minus 3. So therefore, our x in our conclusion is less than a minus 3. Because of an equal to that is on our question, our answer must also carry the equal to. Or another solution, which is this side compared to 4, the numbers 5, 6, 7, 8, and so on. They are more than 4. They are greater than 4. So x is greater than or equal to 4. Because of our question, there's an equal to. Your answer also must carry an equal to. So this is your graphical method, guys. As we can see, the graphical method, we need to interpret graphically how it is supposed to be like. So these solutions, guys, I'm just going to explain the number line. That's the last method I'm going to explain, guys. Other methods, just make sure you go through. So you could also have used the number line to determine the solutions at the end. This is on determining the exact solutions after having your critical values. Remember, I said that on the number line, you must interpret how the number line works. Comparing these numbers, -3 and 4, we know that -3 is on the left side, 4 is a positive, so it's on the right side. So how do we write solutions, numbers that are on this side of -3? We have got -3 this side, -4, -5, -6, -7, -8. These numbers, they are less than -3. So we're talking about values that are less than -3. But just because our answer it is an equal to, you must also put that equal to. So you are supposed to expect a solution this side, or you expect a solution in between -3 and 4. How do you write a solution in between -3 and 4? X will be greater than -3, but less than a 4. I talked about this. Then you just put an equal to when it is like that on your question. Then we've got the last interval of our solution, values which are more than 4. From this 4 going to the right side on our number line. These numbers, they are more than 4, 5, 6, 7, 8, and so on. So these solutions, they represent numbers that are greater than or equal to 4. This is the number line. So on a number line, you must expect 3 solutions. This, or this one, or this one. So how do we exactly obtain our solution now to say X is supposed to be this one? You're supposed to test these. Because we are not saying X is -3, guys. We are saying X is less than or equal to -3. We are talking about any number that is less than this. Any number less than -3. -4, -5, -6, -7, -8. Think of any number of your choice that is less than a -3. That is what it means there. Any number that you think that of your choice that is less than a -3. Any number. You test that number into the inequality and see if you substitute, and in any of these, you can substitute the first one, in the second one, in the third one, just to see, comparing the left-hand side and the right-hand side. So in this case, I'm going to take this second stage. You're going to test using this one, where we are given x squared minus x minus 12 is supposed to be greater than or equal to 0. We want to substitute whatever value that we are having in place of x and see if the left-hand side is actually greater than or equal to the right-hand side. Is it what we are going to have? All right, let's take any value there. We can choose -5. All right, let's just choose any value, guys. We're going to substitute in place of x. So where we have x, we're going to substitute a -5. So we're going to have -5 squared minus, in place of x, we substitute a -5 minus 12 like this is greater than or equal to 0. So we do not know. So we're just going to say we do not know compared to 0. Is it greater than, or it is going to be another thing? So you simplify that on your calculator, guys. This is something that you can simply evaluate on your calculator so that you obtain the number that it was going to give you, 18. So 18 compare with the 0. Is 18 greater than 0? 18 is a positive, guys. It's a greater than. When you talk about being greater than, we're talking about an answer being a positive. We can see that 18 is a positive. It's greater than 0. So when you say this whole part is greater than, it's exactly what we want. What we want is to make sure that the left-hand side is greater than or it is equal to the right-hand side. So you have to compare with your answers at the end. Is it true? Is it maintaining what you were given before? Yes, truly 18 is bigger than 0. So meaning to say this solution is true. It maintains our inequality. It is true. You move on to another term, another number. In another interval, we need to substitute in place of x. In another interval, we are now in this interval, the second one, in between -3 and a 4. We talk about in between. Talk of these numbers, -2, -1, 0, 1, 2, any number that you want. Substitute that number. As long it is in between -3 and 4, you substitute it. it tells us exactly what other numbers are doing. One number verifies for all numbers. If you test with one number, whatever that you obtain for that number, it represents all the numbers in that interval. So you can also prove with another one. All right, so I'm just going to use a 0 there. It's easier to work with a 0. So that's 0 there, 0 there. Going to have minus 12 at the end. So we are going to compare minus 12 and a 0. Is minus 12 bigger than 0? No, minus 12 is less than. So you can see that the left-hand side is no longer greater than 0. It is opposing. Our left-hand side, what we are getting here on the left-hand side, it is less than the right-hand side. But that's not what we want. Our inequality is stating that the left-hand side must be bigger than. It must give us a positive. Here we're getting a negative value. So that means we are not having a solution from minus 3 to 4. In between these numbers, there is no solution in between. So thus here, we do not have a solution. Do not use critical values on your testing of values. Don't use minus 3 and minus 4. Those are critical values. They are not used. All right. So you test the last region. So do not say you're done. You have to test the last one. As you can see, we have our last region there. Values that are greater than or equal to 4. Any number that is bigger than or equal to 4. We're talking about numbers such as 5, 6, 7, 8, 9, and so on. Pick any number of your choice there and substitute in place of x. So I'm just going to take a 5 in place of x. I'm going to substitute a 5 there and test if truly we are going to have something that is bigger than 0. So if we substitute a 5, you are going to obtain 8 if you simplify this. Then let's compare 8 and a 0. Is 8 greater than or is it less than? 8 is bigger than a 0. You can see it's a positive value that you're obtaining. So the left-hand side is bigger than the right-hand, which is exactly what we are seeing here. The left-hand side is bigger than or equal to the right-hand side. So these numbers that are greater than or equal to 4, they're maintaining our inequality. They give us exactly what we want. These values that are greater than or equal to minus 4. So they are part of our solution. So that is how you work with the number line. So therefore, you can conclude that this solution is part of our answers, values that are less than or equal to 4. So that is how you work out the number line concept. So I want you to revise, guys, as much questions as you can. Try to method. As you revise this method, you see that you do not even need much of this time explaining all this. But make sure, guys, you want the introduction. I talked about these subtopics. Let us move on to 1.4. It was an equation, again, that you're solving for x, but that is an exponential equation. We have got exponents that you're dealing with there. That is 1.4. So let us figure out how we're supposed to solve this exponential equation that you're given. It was 2 to the exponent of x plus 2 plus 2 to the exponent of x minus 2 plus 2 to the exponent of x, which is equal to 42. So I referred to this type of an equation when we are given 2 to the exponent of x, or it is maybe 3 to the exponent of x, whatever that you're given. But it is something that is common throughout. You just need to factor that 2 to the exponent of x. It is common here. 2 to the exponent of x. 2 to the exponent of x. So if we factor out the 2 to the exponent of x from the first one here, what are we going to remain with? We remain with the 2 to the exponent of the power, this exponent that you're given, which is 2. Remember, it was supposed to be written as 2 to the exponent of x times 2 to the exponent of 2. So if I factor out this, I'll remain with the 2 to the exponent of 2. So guys, by knowing these exponents now, you're supposed to know that you can remove this, then you remain with the 2 on the exponent. So it's 2 to the exponent of 2. If we remove this, as you can see, we are remaining with an exponent there of minus 2. But it cannot be just an exponent in air like this. No, it must be a number raised to that exponent. So we're going to have 2 raised to the exponent of minus 2 plus, If we remove this, we factor it out. What is remaining? Nothing, it's just a 1. So you're just going to have it as a 1. So that's plus 1 is equal to 42. Just like that. So it is either we can simplify this, or you can just divide by the whole bracket. Or you can simplify this 2 to the exponent of x times, let us just have our bracket, 2 to the exponent of 2, that is 4, plus 2 to the exponent of minus 2, which is going to be 1 over 4, plus a 1 like this. Then you're going to add, that was going to give us 5 and 1 over 4. So you can have it as 5 and 1 over 4, which is fine. Or you can have it as 21 over 4, which is one and the same if you simplify this. All right. So if you simplify this, it was going to give us 21 over 4. So that's 2 to the exponent of x times 21 over 4 like this, which is equal to 42. So like I said, we could have just divided by the bracket there. It is still one and the same. So this is where we are dividing now by this number. We're dividing by the bracket, 21 over 4. We divide by 21 over 4. So we could have used that bracket instead. So anyways, let us cancel this. We are going to obtain 2 to the exponent of x, which is equal to, make sure you divide properly on your calculator. 42 divided to the answer that you got, it is going to give you 8. So that was going to give you an 8. So how can you obtain the value of x? Remember that the bases, if they are the same, if x to the exponent of a is equal to x to the exponent of b, if these bases are the same, the exponents automatically will be equal. So if we've got the same base on these numbers, we can use this concept. So which base can we use? 2 is already in simplest form. So let us use that base of 2. So 2 to the exponent of x. What about 8? Written in this base of 2. We must get it back to the base of 2 because we need same bases. So we need the base of 2. So it is 2 to the exponent of what here, which gives us 8. Is 2. So that's 2 to the exponent of 3. You can try these numbers, guys. 2 to the exponent of 1 to the exponent of 2 until you get the number that is written here. Maybe there's a 64, whatever that. You try the numbers that you are given until you get to that number if you don't understand your exponents. At least what is it that you know? You know that you are in the base of what? In the base of 2. That is the least thing that you must know. So you cannot use the base of 3. You have to use the base of 2 to try these numbers until you get the number that is here. That's a tricky way. Bigger value there that you don't understand. You can use your calculator to evaluate that. Remember the concept that I was explaining, that if these bases are the same, we can simply equate our exponents. So automatically there, our x was going to be a positive 3, as we can see, because these bases are the same. So the exponents will be equal. So therefore, our x was going to be equal to 3. So with this value of x, if simplify the left-hand side, you must on the right-hand side. So the questions can be like that. Questions can be like that, all right? Still on question number 1, given 1.5, you're given, again, to solve for x. That is, you're given an equation under our surds. Remember, your surds allow you to solve equations again, just like exponents. We can have equations under exponents, also under surds. There are equations which we can formulate quadratic equations from there. So given the square root of 4x minus 11 is equal to 2 minus x. Remember, under surds, if you've got a single square root, like what we're given here, this is a single square root. So you can simply remove that by squaring both sides. So you square both sides. That is to remove the square root. All right, the square, remember the purpose is to remove the square. Minus 11 is equal to, there, you expand the brackets. Expansion of brackets, remember this expansion of brackets from a minus b squared, which is equal to a squared minus 2ab plus b squared. So remember, guys, the concept of these identities from a grade 10, because if you know these identities, not going to waste our time. This is your a and this is your b, according to this illustration. This is our a, this is our b. So the question is, we're supposed to have a squared. What is a? 2 squared. Minus, so you're going to have minus 2 times a times b. What is our a? Our a is 2. And what is our b? Our b is x. So minus 2 times x is going to give us, b is what? Is x. So that's plus x squared. Using these identities, guys, if it is a plus here, we are going to have a plus here. So know your identities. If you do not understand this in your FOIL method, Using the 2, multiply everything. 2 times 2 here, it's going to be 4. 2 times minus x, which is minus 2x. You are done with the 2. You move on to minus x. Minus x multiplies the minus x. That is going to be a plus. Minus, minus. So it's going to be plus x squared. So as you can see, we're going to have 4 minus 2 minus 2. That's a minus 4. So that's minus 4x plus x squared. Using the expansion of brackets, identities are also there. It's a choice. We have a quadratic equation because here, the highest exponent, which is 2. So the order, as usual, 1 of ax squared plus bx plus c must be equal to 0. So since we've got our x squared here on the right side, I'm going to leave this side. I'm going to take these numbers to the other side so that that side too, already there, I'm having x squared. So I was supposed to write minus 4x, but I'm not going to write this because there's also this 4x. We take it to this side. So it'll be a minus. So it was minus 8x. You do the same thing on the constant, the minus 11 to the other side. There is a 4 there. So the minus 11 becomes a positive 4 plus 11, which was going to give us a 15. This is where you are. This is where you are, guys. With this, you can now solve the equation that you are having. And remember that if we say 0 is equal to this, it is the same as the right-hand side is equal to 0. You can also rewrite our plus 15 like this is equal to 0, guys. So let's solve. We can try factorization. Coefficient of x squared there is 1. So we're going to just have a direct factorization method, remember, using a factorization method. So in this case, the coefficient of x squared is 1. So you're going to have x here, x here. Let us focus with our constant, which is the 15. Remember, that's our constant here, 15. So we need the products there of 15, but these products must add up to a negative 8. So guys, as we can see, the product is giving us a positive. But when you add, you must get a negative. How is that possible? That you multiply two numbers, you get a positive. But when you add, you get a negative. It follows that those two numbers that you are talking about, they are supposed to be negative values. You are talking about the factors of 15. But as you are using these factors, don't focus with the positive values 5 and 3. You will not get a negative 8 there. Yes, if you multiply, you're going to get a 15. But on the addition, to get a negative, it means one of these must be negative. So you are supposed to focus with the negative values. Minus 5, minus 3, is it minus 15 and minus 1? But when you add these two, you must get the minus 8. So that's minus 5 and minus 3. Minus 5 here, minus 3 here. So let us have our x values. The minus 5 to the other side was going to give us a positive 5. The minus 3 to the other side was going to give us a positive 3. So these are the values of x as of solving our quadratic equation. As we are solving our quadratic equation, this is what we are obtaining. But what about as we are solving our question? Because our question, it has a square root. So we must test these values of x. If we substitute these values of x into this equation, are they going to make sense? Is it going to make sense if you substitute this value of x when you say x is equal to 5? Remember your question before, it was given as the square root of 4x minus 11. It was the square root of 4x minus 11, which is equal to 2 minus x. So we want to start with a condition where x is equal to 5. The left-hand side must be equal to the right-hand side. So you're going to substitute, guys, in place of x. This was going to be the square root of 4 times 5 minus 11 equal to 2 minus our x. Remember, our x is 5. So that was going to be, all right, so it was going to be 20 minus 11, which is 9. Then the square root of 9, guys, is going to give us a 3. But 2 minus 5 is minus 3. 3 and minus 3 are not the same. So you cannot say this is equal to. They are not equal. So x cannot be a 5. All right, x cannot be a 5. Let's move on to another value and test again. If x is equal to 3, are we going to have exactly what is given on this equation if x is equal to 3? So in place of x, we're going to substitute this. So it's going to be the square root of 4 times 3 minus 11. So this is the part of the square root. So is it equal to 2 minus 3? In place of x, we substitute what? 3. So that was going to be 4 times 3, which is 12. Right? 4 times 3, that's 12. Then 12 minus 1 is 1. So it's going to be square root of 11. sorry, we say 12 minus 11, which is 1. So it was going to be square root of 1, all right? And square root of 1 is 1. So this was going to give us 1 on our calculator. 2 minus 1, 2 minus 3 there, which is minus 1. So as you can see, these two, they are not equal. So this was not going to be solution also. So meaning to say this question had no solution according to our simplification of our syllabus. Yes, we do understand that square root of any number is plus or minus. But as they want you to solve these questions, guys, in your syllabus, they want you to solve with positive values only whenever you deal with a square root. When you find a square root, they want the square root that you get from the calculator. Yes, we understand the square root of any number is plus or minus, but in testing of these values, the part of the square root must be the one that the calculator is giving you, meaning to say the positive value. Your calculator cannot give you plus or minus. So in that case, if you get a 1 and another one is a minus 1, they are different. That's the difference part that we're talking about. So in this case, we can say we do not have a solution at all. All right, let's consider question 2.2. Question 2, which is 2.1, solve. It was to simplify without using a calculator. Without a calculator. Just because I've got too many values here, I'm just going to try to rewrite it here so that you can properly see our question. So this was, take note, everything is under the square root. It's under the bracket, like the bracket is covering everything there. Then we've got the square root of 7. This is the square root of 7 to the exponent of 2011 minus the square root of 7 to the exponent of 2009, everything over the square root of 7 to the exponent of 2008. Then, okay, there's a plus. Yeah, sorry, there's a plus square root of 7 there. Take note, there's a plus square root of 7. Then everything is being squared. Remember, I referred to a similar question of this nature and said calculations can be made, guys, in different ways. Then the way that I'm going to explain here might be different from the way that I explained the question. All those ways, they do work. They do work. I say that when we are dealing with the exponents, when you are given a square root, you work with the square root as it is. Everything that is separated under the square root. But we do understand that in our numbers, the one that has got the smaller exponent gives us the highest common factor. All right, look now what is happening. I wanted us to just simplify. The one that has got the smallest exponent compared to everything becomes your HCF. So meaning to say the square root of 7 to the exponent of 2008 must be factored out because that is our highest common factor, the one with the smallest exponent. It must be factored out. Where are we factoring out? From the numerator. Because it's already there. This is what we already see. If we can't factor anything there. But from the numerator there, we can factor out the square root of 7 to the exponent of 2008 because it is the smallest exponent compared all the exponent that you're given. So if we factor it out, we are going to remain with the square root of what? There's a square root here. You factor a square root, you must also have a square root remaining. That is how exponents work under surds. We are now under surds because they are carrying these square roots. So you must have a square root also. So what is going to remain? Remember, to factor out, you simply divide. So 7 to the exponent of 2011 when divided to 7 to the exponent of 2008. How do you simplify, guys? Remember your exponents that you subtract. Same bases you are dividing. You simply have to subtract 2011 minus 2008, it was going to give us 7 to the exponent of 3. Just use your calculator. So that's 7 to the exponent of 3 minus, you do the same thing, you divide, you are going to subtract. So that's 2009 minus 2008. So it will be 2008 minus 2008. So it's going to be 7 to the exponent of 1. Guys, 7 to the exponent of 1 is just same as what? As a 7, like that. Everything over that same square root that you said it is your highest common factor, because it is the one that we refer as our highest common factor, and there's nothing to be factored out there. You write as it is. That's the part of the fraction. But do not forget there was a plus square root of 7 there. Plus square root of 7. It's not part of this fraction. That is why we are not counting this in the factorization process. We are dealing with the part where the fraction is affected by this denominator. All right? So this is what we have, guys. Remember, that is raised to the exponent of 2. So simplifying, we can see that on this fraction, since this is a bracket under a multiplication, division is possible. So we can reduce this. So you're no longer having this fraction. You are just remaining with the square root of 7 to the exponent of 3. All right? Here, I was supposed to have something like this. Here, this after factoring like a bracket there. So you've got 7 to the exponent of 3 minus the square root of 7 plus the square root of 7 here that is remaining. Remember, here there's a bracket, guys, which is now multiplied by what? By 1. So 1 expands the bracket, meaning to say there's no need for us to have the bracket here for these two. All right? Then we add the square root of 7, which is this one, and raise everything to the exponent of a 2. So this is where you are. Collecting the like terms, you can see that these two, they're the same. They can cancel out. Square root of 7, square root of 7. Those two can cancel. So meaning to say, we are remaining with the square root of 7 to the exponent of 3, which is raised to the exponent of a 2. So what are we going to have from there? What is the condition? Remember, the square root of a when raised to the exponent of 2, guys, the square root and the square, they neutralize to give us what is under the square root. So this simply cancels this. Meaning to say, we are remaining with what is under the square root. What is it that we have under the square root? That is 7 to the exponent of 3. Meaning to say 7 times 7 times 7, 3 times. That is going to give us 300 to simplify that one. So questions can be of this nature. And it's like these guys, they'll be testing you. They want you to understand your basics of your simplification. From the basics, simplify it out. You are dividing, so you subtract the exponents. Just because these questions, it was under the square root. So also whatever that you factor out is supposed to be under the square root also. What you're factoring out is supposed to be under the square root. What you're obtaining also is supposed to remain under the square root also. That is the tricky part when it is having a square root, because we are used to questions which are direct. When here we do not have a square root, it's just a normal number. We do not have the square root. If there's a square root, maintain that square root. If it is not there, then it's an advantage because it's not there. 2.2. Solve for x and y simultaneously at the same time, given a linear and a quadratic equation. Remember, we had that activity, which is explaining how to solve such type of simultaneous equations where you're given a linear and a quadratic. So that's 2.2. So the first equation that we are given, it was given as 2x minus y is equal to 3. We're going to take this as our equation 1. And all right, another equation, it was x squared plus y squared is equal to 15. All right, that was our other equation there. So that is it. Those are the two equations, these ones. So I say that when you're dealing with a quadratic and this is equation 2, you work out from the linear equation because it is easier to make x there or to make y from the linear equation. Remember, this is the linear. This is your quadratic, where the highest exponent there is what is 2. So from the linear equation, let us make y the subject. If we make y the subject, It means 2x minus 3. We're going to take 3 to the other side. It will be a minus 3 like this is equal to, it will give us a positive. So it means y is simply equal to what? 2x minus 3. So you can call this our equation 3. Y is equal to 2x minus 3. You make y the subject. So just take this, it becomes a positive. This one, a negative there. Just like that. Y is the subject. From the linear, that is where you make whatever. If you wanted, you could have made x the subject. It's up to you. You can make even x the subject. That is, as you can see, this one, it was easier for us to make y the subject. Then we are going to substitute equation 3, which is the one that we made the subject here, into equation 2, where we had this original of the quadratic. We substitute there in x squared plus 5x in place of y, wherever y is. Our target is on the y here. This one. This is where we need. So in place of that y, we're going to substitute with 2x minus 3. So that is, we're going to just open a bracket there. We substitute 2x minus 3 plus y squared. Y is what? 2x minus 3. So that's 2x to 15. Expand the brackets. As you can see, we've got brackets. Expand. First bracket is by the distribution here. You can distribute this. And the second bracket is this one, which is being raised to the exponents. Where we had this type of equation. All right, anyways, let's expand. First part, guys, just gonna have our x squared plus, we distribute here, 5x is gonna multiply the 2x, that's 5 times 2, which is 10. So that's 10x squared. X and x is gonna give us x squared. 5 times minus 3, that's a minus 15. So it's gonna be minus 15 with x. So that's minus 15x. Let us save this other part of 2x minus 3 squared. So if we expand this, so it is up to you guys. You're going to have those two brackets, 2x minus 3, another bracket, 2x minus 3. I talked about expanding using that of if your gain is equal to a squared. Right? So this is our a. This whole part here represents our a. The 3 represents our b. So they're saying a squared, meaning to say 2x. It's 2x squared, 2. That is 2 squared. X squared, which is going to give us 4x squared. 4x squared. You raise everything to the exponent of 2. 2 is raised, so that's minus x. Here, not the sign. The sign is already here. The sign is already presented there. So you just take the number, which is 3. So if you multiply this minus 2 times 3, it was going to be minus 6 times this 2. All right, that's minus 12. So it was going to give us minus 12x plus b squared, which is the 3, raised to the exponent of 3. To the exponent of 2, sorry, that's a 9. So b squared, it was 4x squared minus 12x plus 9. If you had expanded using that concept of the FOIL method, 2 brackets, you're going to have that same answer. All right, so this is came to that side now, or you can just see waiting the left-hand side, considering where we have got the like terms. We've got the x squared there, plus 10x squared. Also have the 4x squared. Part of x, we've got minus 15x here, minus 12x. Then we just have a constant, which is 9. All right, so let's consider the part of x. So that's 1 plus 10 plus 4, which is gonna give us what? 15. Take note, 1 plus 10, which is 11, plus 4, that's 15. So we're going to have 15x squared. Okay, we move on to the minus 15, minus 12. So minus 15 minus 12 is going to give us minus 27. So that's minus 27x plus a 9, which is equal to 15. Take the 15 to the side, so that is going to be a negative there. So we're going to have 15x squared minus 6. Okay, that's equal to 0 like this. Guys, this equation, it's going to depend. You're going to use quadratic formula, factorization, but at least just try to reduce this equation, guys. 15, 27, 3, and 6. There you can see that 3 is common, so you can simply reduce by, so that was going to give us 5x squared minus 9x, and this one was going to give us a negative 2. That's equal to 0. All right, so this all these like substitutions that we had, expand it properly, collect your like terms, depending on what you're given, you have an equation like this. Using your quadratic formula, you can solve for x, or you can use your factorization method. Remember, so you can use the quadratic for factorization. Choose the one that you are used to, guys. Okay, I also explained this one of the cheat method. Let's try to use our cheat method. Remember, I said it's 5x squared minus 9x minus 2 like this. Since the coefficient of x squared here is not a 1, it is not 1, as you can see, there's a 5 there. We are supposed to remove this to steal out this 5 to the constant. All right, so we steal this 5, multiply it to the constant, apply it to the constant. So it is going to give you x squared. Remember, you have removed this 5, so it is now 1x squared minus 9x, 5 to this side is going to give us a negative 10. Okay, 5 negative 2, you get a negative 10. Factorize as usual because we have got the coefficient of x squared as a 1. So you do factorize as usual. So you're going to have your x here. You consider negative 10, the products of negative 10, but these products must add up to negative 9. So definitely we must think of negative 10 and 1. Multiply this, you get a negative 10. If you add this, you get a negative 9. Thus, we've got a negative 10 and a plus 1 like this. But this is not our final answer as of what we had. Remember, we removed the 5. We stole this 5 and used it on another calculation. We have to bring back that 5. So that is the condition here. Bring back the 5 in place of x, in place of x. Then factorize where possible. The first bracket, 5 is common, so we can factor out the 5, which is common in this first bracket. 5 is common. So we're going to remain with x minus 2 into the second bracket. There is nothing there to be factored out. So the number that you factored out is not part of your answer. Remove it. Get rid of that. What is remaining here in these brackets are the ones that we need here. So this is the factor here, guys. You just see the memo there is giving you these two brackets. You're wondering, where are they being taken from? It was a factorization. So that factorization, use method that you are used to, guys. I explained different methods. Choose the one that you want. I also explained this one, the cheat method. Make sure that you watch the video to understand more. So let's take this one, guys. These are our brackets. X minus 2. You move on to another. Try. Work out as many questions as you can to understand this factorization method. It needs a lot of practice. Once you practice these questions, you see that you do not have a challenge on that factorization part. Then you can determine our x values. So minus 2 to the other side of the equation is going to give us a positive 2, or x is going to be what? 1 to the other side was going to give us a negative 1. Then we divide by the 5 that we are given there. So it is going to be negative 1 over 5. Or you can write this as negative 0,2. So like I said, after this, guys, at this stage, you can also use a quadratic formula. You can use a quadratic formula, guys. If factorization is difficult at that moment to say, you can use a quadratic formula. You have the two possible values of x, but we need also the y values. So where are we going to have the y values? Remember, we made y the subject in equation 3. We made y the subject of the formula y is equal to 2x minus 3. So you can substitute now into that equation where y is equal to 2x minus 3. The x value that we got in the first place. So y is going to be 2 into our x, which is 2 minus 3. So y is going to be what? 2 times 2, that's 4, minus 3, which is 1. All right, so the y value is going to be 1 there, or y is going to be equal to, if our x is negative 1 over 5, meaning say in place of x, we substitute negative 1 over 5 in place of x. That is what we are going to have there. So working with this one, you are going to obtain, that was gonna be, all right, there's a minus 3 there, 2x, all right, minus 3 there. So this is going to give us negative 17 over 5. So these are the possible values When x is 2, y is equal to 1. That is what it means. When x is minus 1 over 5, y is equal to what? Minus 17 over 5. So with these solutions, that is, we are done, guys. This one, we do not have any special format where the square root is, where we need to test our values. This and yes, you can just see, you can just use those values to see if you're in the right direction. That is in terms of the exam. In terms of your under exam, you can just substitute when x is 2 and when y is 1. Are you having the left-hand side being equal to the right-hand side if you substitute that condition? If you move on to another condition, is it going to give you the same thing? All right, so that is how our questions, guys, might be like in other cases. And on question 2.3, we are given to discuss the nature of roots of the following graphs. The nature, discuss them. On a function like this one, we do not have the roots. Remember, the roots, they are found in the x-axis when the function or when the graph crosses the x-axis. That is where we have the roots. If the graph is not passing or crossing the x-axis like this, it is just going back without passing on, without crossing the x-axis. There is no solution in that nature. There is no solution at all, meaning to say we are talking about non-real roots. This is a condition where our discriminant, which is our delta, must be less than 0. Where we simplify, we've got something like x is equal to minus 3 plus or minus the square root of minus 4 over 2. When the square root is having a negative value like that, there is no solution at all. That was at the non-real. That is the condition, the discriminant, which is our delta there. The b squared minus 4ac will give you a negative. That it's less than what? It's less than 0. That is that is the condition of a typical graph of this nature. Using this one, 2.32, we can see that it is crossing, it is just passing through the x-axis. At that point, it goes back. It's a solution, this one. It's very true. It's a solution. But we have got the same solution. We have equations where we solve, then we obtain two solutions which are the same. X is equal to minus 3 or x is equal to minus 3. How does this happen? It is a condition when the number that is under the square root is a 0. The number that is under, let's say here we've got, let's say minus 6 over 2 like this. The number under the square root there is a 0. Our delta is directly equal to 0. So in that case, you have same roots, which is equal roots. So these roots, they are real, rational, and equal. They are real, they are rational, and what? And equal. That's a condition when our delta is directly. 2.4, we are given the solution of the quadratic equation is given. You were solving a certain quadratic equation. This is how you wrote it. Determine the value of k for which these x values will be rational. Just to be rational, we have got rational solutions if our values or if the discriminant that we are given there, remember b squared, guys, b squared minus 4ac is the one that our delta. You compare with that delta. And that b squared minus 4ac is this part that is under the square root. Remember, b squared minus 4ac is the part that you find under the square root. The square root of b squared minus 4ac, this one, under the square root. So as we are comparing our delta, for us to just have a rational solution, it means that our delta must be greater than or equal to 0. So whatever that we are given under the square root, representing b squared minus 4ac, the 13 minus 2k that we are given is supposed to be greater than, bigger than, or equal to 0. So we can solve an inequality. Take the 13 to the other side, it gives us a positive. So minus 2k is greater than or equal to minus 13. It was a positive, so it will give us a negative on the other side. Divide by a negative, Remember I talked about this solving inequalities. The moment you divide by a negative like this, the moment you use a negative, reverses. The inequality sign reverses, changes. So it is going to be less than or equal to now. All right, so this can cancel negative, negative. That is going to be 13 over 2. So this is what we have for all values that are less than or equal to 13 over 2. For all these values that are less than or equal to, we can consider that we're going to have rational values. But there we have to be careful because it's about the rational, guys. As to have rational, remember that is when we are supposed to have perfect squares in terms of the presentation there. Whatever that is under the square is supposed to be a perfect square. Remember, we are not supposed to have those endless days. We are supposed to obtain fractions that is being rational. So considering that, we can use it to answer this type of a question under exam condition. That is what they would need you to attempt this type of a question. On question 3, which is under trigonometry 3.1, you are given if tan of theta is minus 2 over 3, and the sine of theta is greater than 0. Calculate by using a sketch. The sketch is needed. That's why they are giving us conditions about the tan of theta. It is what? A negative value. The sine of theta is greater than any value that is bigger than 0. We're talking of what? Positive values. So we want a condition, or we want a quadrant where tan is negative, but in that quadrant, sine is positive. That is why the sketch is needed. Do we have a condition like that, guys? Do we have a condition like that where tan is positive and sine is negative? From our cast concept, this is what we understand. So we need, let's start with the positive because tan is negative. So let's focus with where sine is positive. Sine is positive where? In this quadrant of sine, and in this one for all, of which in this one for all, tan must be positive. But in this case, our tan is what? Negative. So the first quadrant is not going to work. So we are going to focus on the second quadrant. Is it true? In the second quadrant, is tan a negative? Yes, that's a negative because sine is the one which is positive. So everything becomes negative. Tan becomes negative. Cos becomes negative. In this third quadrant, it is a tan which is a positive. But here a tan is supposed to be negative. So it fails this one. So our solution was going to be determined from the second quadrant, meaning to say in the second quadrant, you were going to have a sketch of a right-angled triangle. Remember, these ratios are taken from our trigonometrical ratios, which are the properties of a right-angled triangle. These are the properties of the right-angled triangle. All right, so we are given the tan of theta. That's negative 2 over 3. Remember from your SOHCAHTOA concept, tan is opposite over adjacent. So we've got opposite there over the adjacent. So what is opposite according to this? Let's say this is your theta. The opposite here. Guys, where am I? All right. So the opposite here, we can see that it cannot be a negative. It's a positive. So how do we change? Because we can see that it's negative 2 over 3. So remember, a negative can be like this, negative 2 over 3. It can be 2 over minus 3. Still one and the same thing. So meaning to say when it does not make sense on your graph, on your sketch, but you have your sketch drawn properly, but does not make sense, change the sign. So you're going to put this in the denominator. So it is the same as we've got 2 over minus 3. Let's try and see if it's going to make sense. Opposite is 2. This is the adjacent. Can this be a negative 3? Yes. Remember, this is the x-axis. The left side of the x-axis is a negative, is where we have our minus 3. If we use opposite over adjacent, our minus 3 is same as what? Minus 2 over 3. We haven't changed anything. But we must be very sure where the negative is. We cannot have a negative 2 here. No, that one is not possible. So it was important there to figure out this. All right, anyways, we are told that the sign is positive. As we saw, this is the quadrant where sign is positive. So the question now was calculate using the sketch. With this sketch, the cos of theta times the sine of theta. So the cos of theta times the sine of theta. We need to fill in our triangle first using your Pythagoras theorem. Remember that R in this case here, R squared is equal to x squared plus y squared. Meaning to say our R squared is going to be 2 and this one. So you're going to even start with x, which is minus 3 squared plus 2 squared. So R squared is going to be 9 plus 4, which is 13. All right, so that is 13 there. So you're going to have our R squared being equal to 13, which is our hypotenuse. So if hypotenuse is equal to, if hypotenuse squared is 13, what about the hypotenuse? Introduce the square root. So that was going to give us the square root of 13. So here, our hypotenuse is the square root of 13. We used Pythagoras theorem to fill in our triangle. Then we can now complete the statement. Cos adjacent over hypotenuse according to theta. Remember, I said this is our opposite. This is our adjacent. This is the hypotenuse. So we need adjacent over the hypotenuse. That is what we need there. So what is the adjacent? Minus 3 over the hypotenuse, the square root of 13, times the sine of theta. What is the sine of theta? Opposite over hypotenuse. The opposite is 2, and the hypotenuse is the square root of 13. So this is 2 over the square root of 13. So let's simplify, guys. You can multiply the numerator to the numerator. Remember, multiplication concept. Denominator to the denominator. Or at this stage, you can even use your calculator. It does not matter there. So this was going to give us minus 6 over square root of 13 times square root of 13, which is 13. So that's minus 6 over 13. So let's do revise, guys. As many questions as we can see that it'll be just a repetition. You see, you've answered questions like these before, similar to these ones. You just have to notice, work out as much as you can. Simplify the following expression to a single trigonometric ratio. So we need to apply our ratios in as much as we can. Remember your positive, negative angle, sine 360 minus x. From our reduction concept, 360 minus x is an angle which lies in the third quadrant. In the fourth quadrant, these are positive angles. Remember from the cast concept, let me also present this. In terms of the positive angles, this will be x. This will be 180 degrees minus x. This will be 180 degrees plus x. This will be 360 degrees minus x. Remember your positive angles. In terms of the negative angles, we understand that this will be representing minus x. This will be representing x minus 180. This will be representing minus x minus 180. This will be representing x minus 360 degrees. These are negative angles, the one that I'm putting in green. Those are negative. They are called negative angles, but they maintain the same property as what we have in that quadrant. They maintain the same property. Same property. All right. So 360 minus x, it's a positive angle which lies in the third quadrant, in the fourth quadrant, sorry. And in this fourth quadrant, sine is a negative because the sine is the quadrant for what? For cos. That is for cos. This quadrant is for cos. So it means sine here is what? Is a negative. So that one is going to give us a negative sine of the acute angle, which is x. So it's negative sine x. Multiplied to x, it's an angle which is also in the fourth quadrant, but this one, it's a negative angle. 360 minus x represents positive angles. Minus x, that one is a negative angle, but it still lies where? What is important is where it lies in the fourth quadrant, which is the quadrant of a cos. Not for tan. Tan, this quadrant is a negative. So if tan is a negative, it means this was going to give us negative tan x. We've simplified that. So that's negative tan x. Everything over what? We move on. Cos 180 degrees plus x. Where is 180 plus x? It's a positive angle, which lies in the third quadrant. And in the third quadrant is the quadrant of a tan, not a cos. It is for tan. Cos here is a negative. Cos is a negative in the third quadrant. So if it is the quadrant for a tan, which means cos there is what? It's negative. So this is going to change to a negative cos. That's negative cos of x. Multiplied to sine squared a plus cos squared a. Remember your Pythagorean identity. Sine squared x plus cos squared x. Is it sine squared z plus cos squared z? As long you have got a squared and a squared, same letter or same number here, we are going to get a 1. That's our Pythagorean identity. Cos squared x is equal to 1. So it's an identity that you need to know. So with these guys, we can now simplify further. We reduced everything that we had. Now we can simplify further. Okay? So we do understand that we can use the sign to say tan is sine over cos. Guys, that one is up to you. You can use it that way. But are you seeing that we have a sine and a cos here? Sine and the product here, this division of a sine and a cos, we can reduce this. Sine over cos is equal to what? Tan. Remember that identity of a tan. It is the tan of x multiplied to what? You divide what is remaining here. Minus tan x divided by 1. It's what? It's minus tan x. It's a product, this one, of tan x to minus tan x. So that's minus tan squared x. Tan squared, tan x squared can be written as tan squared x. So if you are given like this one, minus tan squared, because there's a negative there, it means minus tan squared. The negative is something else. It's on its own. It's on the sign. Plus and minus, that's a minus. But tan and tan gives you a tan squared. So you can even write it like that. Not this way, not minus tan x squared like this. This is totally wrong. The 2 there is not on x. No, it affects the tans, direct on the tan like this. Or if you want, you can have it in bracket, then you square it like that. You can not to say it's on x squared. No. That one is a wrong presentation at all. A total wrong presentation. So that is a single trigonometric ratio that we are obtaining at the end. Just like that. 3.3, prove the identity. You're supposed to prove this. Whenever I ask to prove it, it's that the left-hand side, it is supposed to be equal to the right-hand side. So in cases I talked about identities also, that some identities are difficult to prove that the left-hand side is equal to the right-hand side. Some identities are direct. If you do have a condition where it is not direct, you simplify the left-hand side, you get your answer. You simplify your right-hand side, you get your answer. I'm saying some questions. It is not always. But in this question, we are going to try and work out from the complicated side, from the right-hand side. So from the right-hand side, that is where I'm going to choose my question. It is much complicated there. I'm given 1 minus 2 cos squared theta, everything over the sine of theta times the cos of theta. We are supposed to prove that it's supposed to give us this as a tan minus cos, something like that. All right, so this is how you prove, guys. Just ask yourself for any equivalent identities, any equivalent, anything equivalent to a certain identity, like a 1. Like a 1. We talked about this one. We saw it here. Sine squared plus cos squared gives you a 1. That is what we said. We got a 1. It's a proven identity that you just need to apply. So we saw that if there is a 1 like this, it was taken from what? Sine squared plus cos. Okay, let's see if it is going to make sense in our simplification. So 1 is same as sine squared, okay, in terms of theta. If they use x, you write it in terms of x. If they use a, write in terms of a. So that's sine squared theta plus cos squared theta. We have replaced the 1 with its equivalent identity here. All this identity that we are seeing here is same as 1. We just removed a 1 and placed that identity. That's what I'm trying to say. Okay? But what are we having there later on? We remain with what we had, minus 2 cos squared theta, everything over the cos of theta. This is where we are. So looking into our question, we can see something familiar, which is the cos squared minus 2 cos squared. These are like terms, so you can even subtract. This is the same as 1, so 1 minus 2 is minus 1. So it is going to give cos squared theta. It was supposed to be minus 1. 1 minus 2, that's minus 1. So minus 1, guys. There's no need for you to write that. Just leave it like that. Everything over what? The sine of theta, the cos of theta. This is where you are. And at this stage, I want you to be very, very careful, because if you consider your answer there, I want us to check our answer properly. We can see that it's a separated question there, because we want to prove that the right-hand side is equivalent to what we see on the left-hand side. So looking into our left-hand side, because guys, you are proving, but the answer is there. So also read the mind of the answer to say, what is it that we have on that answer? They separated this to have a term minus another term like this, guys. It is simply showing us that they separated. So from these two, let's try to separate and see. Remember, I said A minus B over C is the same as A over C minus B over C. As long as you are separating this, provided that you are using the same denominator on each term. This term, the sine squared of theta over our denominator, which is the sine of theta, the cos of theta, minus the cos squared theta to the denominator again, separated like that way. So this is cos squared theta, everything over what? The sine of theta, the cos of single term. This one, remember, it's a product. We are not adding sine plus. No, it's a single. When it is like that, it's a single term. So it can be separated like that. So here we can see that they're like terms. They are terms that are common. So the sine into sine squared, we are going to remain with the sine of theta. Okay? The cos into the cos squared, we are going to remain with the cos of theta there in the numerator. So meaning, say, from the first fraction, when we divide sine and sine, it is going to give us the sine of theta over the cos of theta minus cos, right? It's going to give us the cos of theta over the sine of theta. So if you look closely, guys, in your grade 10, you're working with those identities, the cot, the sec, the this and that, you're working with those identities. But if you move on to your grade 11, they try to avoid those identities. That is why you see here, they simplified the first one. The second one, they just left it as it is, cos over s. Because to prove, guys, you are given an answer. So try also to figure out, is it true? Sine over cos. Sine over cos, that's a tan. So that's tan theta minus. This was supposed to give us cot theta like this. It was supposed to give us cot theta. But because it is not simplified there, leave it as it is. So it's cos theta over the sine of theta. So that is exactly what we are given, or what we have on the left-hand side as we work out from the right-hand side. So you can also try work out from the left-hand side till to work with the most complicated side. The right-hand side was the most complicated. We have a lot of things to be done compared to the left-hand side. So it is best that you prove from the complicated side to the easier side. So these are the typical questions, guys, how they can be given as from your solving of equations, simplifications of your algebraic expressions. Much exam. You just need to work out just as many questions as you can. Make sure to go through the topics, introductions. Also, they are important. Don't just revise question papers. Go through the introduction, understand the topic. What is it all about? Then you see that all these question papers, guys, are just nothing. We're doing nothing here. Just nothing. Let's just work out the introductions. So that's it, guys. Till we meet again.